Now let's learn draft. Now draft is also available separately in Feature Command Manager as a feature. So it taper the faces using specified angle to selected faces in the given model. The part can be easily removed from the mold during the manufacturing process, like casting, molding and 3D printing. So draft is allow easy removal of part from the mold. For example, let's say we have this kind of a mold. Now the part is also provided with draft. So moment we lift it, there is a direct detachment between the mold and the part. So it is not going to touch to any part of a mold. So it will remain safe. So this way the draft will helpful in removal of a product from a mold. Now there are three types of a draft: neutral plane, parting line and step draft. If you look at this property manager, there are two methods through which you can apply the draft. One is manual and second is draft expert. These are similar to the fillet. Now in case of a neutral plane, you have to choose one plane that stay fixed, that is neutral, and other faces will be tilt around it. Here for example, this face is neutral and all the other faces are simply tilting around to create the draft. They may be this direction or maybe on negative side, or you can say opposite side. Now on parting line, instead of neutral plane, you choose parting line from which the draft spread in both the directions. So for example, this is parting line which divide the surface in two parts, part 1, part 2. So this part 1 can be given a separate draft with respect to 2. In step draft, basically it's an extension of parting line, but it creates a step, then applies a draft on one side of that step. We'll see all these three types of draft through exercise. So in 7.2, we'll explore neutral plane draft. 7.21 we'll try to explore the parting line draft. And 7.22 we'll try to explore the step draft, which is extension of parting line through example. Now open the exercise file 7.20 neutral plane draft. Now the draft feature is located in Feature Command Manager as a separate features. So click on draft. Now choose manual method and inside that let's apply the neutral plane. Here we have to choose first the neutral plane. In this exercise, I'll keep this top plane as a neutral plane. So go ahead and select it. Now I have an arrow over here. At this moment, it is pointing upward. I can change the directions downward and upward. We'll see the effect of this change of directions. Now secondly, we have to choose faces to draft. So here I can choose 1, 2 or many faces to which I want to apply a draft. Now consider the value. Let's say I want to apply a 15 degree. Now click on show preview. So it will give you a preview that will let you know what is going with the part. Now if I change this neutral plane directions, see what happened. The material get removed and draft get added inside. So based on direction of this neutral plane, either you will add the material to the surfaces or remove the material from the surfaces to create the draft. Now under the face propagation, we have 4 options. All faces mean inside outside, because we have a solid part over here. So there are only 4 faces selected vertically. If it is hollowed part, then there are 4 more surfaces. So they are also get selected for the draft features. Second, outer faces, inner faces separately, all faces and the tangent propagation. For example, at this location we have a tangent, then if I choose this face, it also get propagated to the second face. Now as of now, select none and click OK. So this way, by using neutral plane, you can add the draft. Now let's edit the draft. Now let's change the direction and click OK. Now look what happened here. The draft get inverted because of a change in direction of neutral plane. Downward means you are pulling inside. Upward means you are pulling up direction, but this will tilt outside. So it will add the material. Now let's go ahead and change the direction. This time I will clear the selection and I will choose only two face and click OK. So draft will be only applied to two faces. How do I know? Select this top face and normal too. So you can see these are only two faces to which the draft is applied. Now let's go ahead and edit again. Clear this selection, clear the face. Now this time I will choose neutral plane over here. Now I will choose this top face and bottom face. And I will apply the angle of 20 degree. Now click OK. See the result. Now let's go ahead and edit again. This time I will change the value to 10. And I will remove the selection again. And I will choose the original plane that we have used earlier. This time only I will choose this face. And right click to complete the draft. Now let's roll back to the draft features. Now let's apply a fillet of 10 to vertical edge. Click OK. Now let's roll back to the draft features. Now it says error. So let's see what's the problem. Here, because we have choose this face, but before that we have added this fillet. So instead of this face propagation method, we have to choose allow tangent. So it will continue the draft from this face to this face and click OK. So this is the meaning of allow tangent propagations. Now open the file parting line draft. Here we need to divide or part out the surface. So we have to split it. So we can do that through sketch. So select this plane and create a sketch. Now let's draw a line. You can dimension it if you wish to. Now go to the feature command manager. Under the curve, select the split line. Here we have to choose the projection method, and already the current sketch is selected over here. Now we want to split the surfaces, so we have to choose them. So this face, this face, this face and this face. So what happened here? This sketch will be projected horizontally and it will split the surfaces, these all four selected surfaces, in two parts. So let's click OK. Now let's select the surfaces. So these are individual surfaces generated through split line command. Now let's apply draft to these surfaces. This time I will choose parting line. Now here I have to choose first the pull direction. So I will choose this top surface. After that I have to choose parting lines. So I have 4 lines, 1, 2, 3 and 4. If I choose only 2, then the draft will be applied to only 2 selected surfaces. So I will go ahead and select this line and this line. So because of that, the highlighted surface will be subjected to draft. Now here the angle is 10 degree. Now let's click OK. Before that, let's see the preview. So here the draft is applied from the split line. Earlier in neutral plane, entire surface get drafted. But here, because of the line which we use as a split line or parting line, we'll divide the surface in two parts, so we can separately draft out them. In case I want to add few more lines, then go ahead and select this line and this line. So we have 4 parting lines, and because of that we have 4 surfaces for same purpose. Now let's click OK. See that we have a draft using parting line. Now let's edit the feature. Now here I am going to select all these 4 edges. So select one, then press Shift and select the last one. Now click on other face. When I click it, try to observe what changes you have seen. So other than that, what SolidWorks does here is it simply switch the selection of faces. This is the meaning of other faces. Earlier it choose the surfaces which are in line with this arrow. So because we have chosen other face option, so other faces below the parting line get selected. Now let's increase the value from 10 to 15 and click OK. So because the pull direction was in upward, so obviously these faces are tilting outside. Now let's go and edit the feature. Now here the 4 edges that we have used, let's say I want to taper only one face, then I have to remove the remaining edges like this and click OK. So only that face will be drafted. Again, let's select all the parting line. Now select all and select other faces. Okay. So this face is reversed. So let's make it to along with the other faces. Okay. So all are in one direction. Now similarly to that, we have along the tangent propagations. If we have a tangent edge over here, it will continue. Now here we do have a direction too. If I tick this, the draft for the other faces also get activated. Now because of that, the other face button is disabled. So this 2 direction means we are applying draft to all the faces which are parted by the lines. Here we have 8 faces. Either you can go for symmetric draft value or asymmetric draft value by adding the value manually. Click OK to see the results. So this is the benefit of parting line draft. Now open the exercise 7.22 parting line draft with stepped options. Start the draft. Instead of parting line, I will choose step draft. In the part 5 already the sketch is provided and the surface are splitted. Here the pull-in direction is on a top side. Now for parting line I will choose this line, this line, this line and the remaining line. If I wish I can add the other side lines. So here in this sketch we have 5 segment of lines. Now I have selected total 9-10 edges, front side 5 and back side 5. Now under the step draft we have 2 options, tapered step and perpendicular. Now let me apply 10 degree and let's see what is the results. So click on the show preview. Observe very carefully what is happening here. because these two arrow, parting line arrow and the pull direction arrow in one direction, so it add the material to the parting line. Now here, because we have chosen the taper step, let's see the outcome. The faces are tapered with respect to the selected face, or you can say this face. That is the meaning of tapered. Look at very carefully. Okay, so right click, select the normal. Let's see the hidden view. So this is selected surface, and with respect to that we have added the taper to the draft at the parting line. Now let's edit it and try to apply the other options. Here let me choose the perpendicular to step. So let me click on show preview and let's zoom in and select the perpendicular to step. So look at what happened. Let me switch back and forth. Again over here, back and forth. Okay. Now let's go ahead and click OK. This time let's select this and click normal. So here the surfaces, these draft surfaces remain perpendicular to selected surface, that is this one. In earlier case, that is in the option of taper step, they are remain at an angle with the selected surface. Let's click and try to see. So this is having inclination with the selected surface. Same is also observed on other side. Now let's try to flip the directions. So select this, the first edge, shift select the last one and click on other face. And I will keep the direction upward and click apply. To see what happened here. This surface remain there and the bottom face is tapped out. Now let's add this line and this line. Okay, so here I will choose the other surface for the 11 as well. I will choose the other surface. So all the faces are pointing downward, and let's click OK. Because this line is plain line, so it is having a uniform draft, step draft. But here we have like a trapezoidal shape. So this way you can use draft feature to create a neutral draft, parting line draft and step draft. Now let's learn cell feature. It's available in feature command manager below draft feature. It basically makes a solid body hollow from inside and leaves open the face you selected and create the thin wall feature on remaining faces. So look at over in this image, I have a solid part. I have applied the cell feature, so it hollowed out from inside by leaving uniform thickness provided from each surfaces. If I do not open the surface, the entire part remain hollow, but it is closed from the outer surfaces. Now where do the cell feature is used? Basically used in plastic parts, enclosures, bottle cap, thin walled sheet metal parts and any light hollow part. Now remember, a cell feature to work, you must have a model where minimum outside curvature, that is convex curvature, is greater than the cell thickness. Now remember, to work a cell feature, the minimum outside radius or curvature must be greater than the wall thickness provided in cell feature. What does it mean? Let's say I have this kind of a surface. Now this radius is 10 millimeter. Now I'm going to create the cell feature. I'm going to apply the cell feature with the wall thickness of 3 mm. So 3 mm will be left out, and so inside radius which will be created will be of 7 value because 3 is deducted. If the wall thickness is more than this value or equal to this value, then just imagine what will happen. It is going to create, if it is equal, it is going to create the start solid line or solid edge. If it is more than this thickness, let's say 12, it is not able to create or apply cell feature for such situations. So that's why you have to remember this one condition. We will learn how to apply cell feature through exercise. So here in cell property manager, you have to apply the thickness you want to leave from the surfaces, and you have to choose the surfaces you want to keep open. Either you can go cell outward or inward. So let's explore the cell feature. Through exercise 7.24, we will apply cell feature and try to create the ice tray. Now open the part file 7.23. Now go ahead and start the cell features. Here I will going to apply 5 mm wall thickness. So if I do not choose any surface to be remain open, then let's see what happened. Click OK. See, entire part is hollowed out. But because we haven't selected any surface which we want to keep open, because of that we have no idea whether it is hollowed out or not, and edit the cell feature. This time I will choose this surface and this surface to remain open and click OK. So it removed this top surface and this inclined surface. Now let's go and edit again. Here what I want is, I want uniform thickness from all surfaces except this back side, that is this surface. From this surface I want the thickness of 5 mm. So select over here and add the value of 5 mm or maybe any value you want, let's say 10 mm. And choose the selection box and select this surface and click OK. So what happened? All the other surfaces having 5 mm uniform thickness, but the selected surface, from that surface the thickness we applied is 10 mm. So this way, using cell feature, you can apply uniform thickness or a specific thickness to a particular surface. Now open the part file 7.24. Here let's go back to the first feature. I have created a rectangle block. On that I have created extrusion in which I have added the 5-degree draft. So draft is also available inside the extrude feature. Now then I applied the radius to all its outside edges, that of 3. Then I have added fillet 2 to the upper block having value 15. Then I simply linear pattern the feature. So it's a distance having 60 in x direction, and in y direction it is again 60. But in one direction they are 4 and in second direction they are 2. Now let's try to apply cell feature. Now I want to leave 3 mm wall thickness from these outer upper block surfaces, and the rest of the surfaces, that is this bottom part. So I will have to choose the top surface to open. From here I will choose all the surfaces by selecting tangency. So from this pink surfaces, cell feature will leave the 3 mm thickness. Other than that it will be 2 mm as shown over here. Now let's click on show preview. If it is OK, go ahead and click OK. Now see, This is the outcome. Now let's try to edit this feature. Now here, instead of 2, let's add 2.5 or say exactly 3. Now let's try to add the cell. Now see what happened. The inside surface do not have any curvature or fillet surface, though it has a fillet outside. Because this is of 3 value and I am adding the wall thickness at 3 mm. So 3 minus 3 is 0. So it leaving the sharp edge. So here let's apply it again 2.5 and update it. And see that is a 0.5 millimeter of radius. So here you need to take care of the wall thickness value based on the outer curvature fillet radius. This way, by using cell feature, you can create the ice tray.